you're gonna faint.
Was that
Do I need to buy it?
Yes.
I want
My seat.
You can do that. You need a pen and a ruler. You see if you've got a pen and a ruler, otherwise a straight edge will do. Not all that top just leave that on. Have you got a pen and a ruler? Okay. Welcome to a new unit called Mathematical Methods Unit 2. So, whatever you do in Unit 1 doesn't count unless you're doing methods next year, and then it counts a lot. Because we want to remember as much as we can. I will give you your exams back on Friday in the double. So I need to start and get us going through this topic. I will give you back and we'll run through some solutions. And over the holiday break, I won't give you lots of work, but one of the tasks I will do is give you another copy of the exam to go through. If you've done something really well, it won't take long to copy it across. Maybe the people who got highs and very highs don't have to do it. But to have a look at the ones you didn't do well, and to actually go through and write those up, and to submit that on the first day back, some improved solutions. Remember, the purpose of doing that exam is because we have to get good at exams next year. That exam was the 1 hour exam, like in Year 12, you get a 1 hour exam, no calculator, no summary book. But the next exam we get, like in methods we get 2 exams, the next exam will be a summary book. So I would really encourage you to keep your summary book up to date as you go along when we get ready for that exam. And that exam will be 2 hours long. So exactly the same as Year 12. Okay, trigonometry. This topic is a little bit different. We're sort of, again, learning a new language, and we're going to learn about this thing called the unit circle. But we're going to start from basics. The people who take some time to understand the concepts, the people who can really work out whether they understand it today, but eventually get what I'm talking about, do really well in this topic. Everything that we've done so far in Year 7, 8, 9 has been about coordinate geometry. It's about how do you get to a place? You start at the origin and you go across and you go up. We're going to change that around now to say if we start at the origin, we might measure an angle from the positive direction of the x-axis and we'll go a distance. So instead of having an x and a y, we're sort of going to have an angle and a distance. So it's going to change things around and enable us to do a lot more things in math. So this comes up in lots of other topics. We'll do calculus. This comes up in calculus as well. But today, I'm selling you these things. 1, sine theta equals the height. We're going to work that out ourselves in the booklet. We're going to discover cos is the length. We're going to work out that there are equivalent angles in a revolution, whatever that means. And I'll point these things out as we go. And if you're changing from degrees to radians, there's a rule, and radians to degrees, there's a rule. But we're going to come across those things. So today's lesson isn't, let's go and do exercise A. It's going to be, let's get a feeling of the subject. And the people who understand about what I'm talking about, heights and lengths, if you get that concept, it really helps. So maybe going home, and playing with a little interactive, we could do that really well. Have you got, laptop away please, have you got a little booklet? The first one says, an activity, got a ruler. Could you draw a right angled triangle with a hypotenuse of 1? Now I've got this thing called a unit circle, and it's called a unit circle because it's 1 unit. From the origin, you go to distance of 1. Up here, distance of 1. So a unit circle, and I haven't defined it, it's just a circle with a radius of 1. So if you draw a triangle in like I've got, you can see it's over there on the right as well. Could you draw that one in, please? I've drawn it up to the first dot so you can make it nice and easy. There's my triangle. It's got a hypotenuse of 1 because the circle is a radius of 1. So this is pretty easy stuff. So we're going to learn about this. So draw a triangle with a hypotenuse of 1 angle of 30 degrees. Use trig to calculate the height. Which is the height? The 1, the height, or the length? It's obviously the height. So can you put a Y on there for your height? And we're going to do some calculations. Is there a spot to do some calculations? Yep. So where it says on yours 30 degrees, let's do that. We're going to do an angle here and we've got 30 degrees. This is the, what side's that called? Opposite, hypotenuse, adjacent. Opposite and a hypotenuse. Hopefully you remember SO, CA, TOA. If you don't, we'll have to get good at that exam. But let's write that down. It's an opposite and a hypotenuse. Sine, better write the rule first. Theta equals opposite over hypotenuse. What's the angle? The angle's 30. How much is the opposite? Y. And how much is the hypotenuse? Hypotenuse is 1. And this is where a really big point is, it's always going to have a 1 on the bottom line. So, y equals sine 30. Has anyone got a calculator and to work out sine of 30? Or do you know what sine of 30 is? That's what we learned. What was it? A half. I'm going to write it as 0.5. A half. If you've got an angle of 30, the height is a half. Could you measure the height? Let's have a look over here. There's the 30 degrees. How high is that bit there? That distance there is the same as that distance across there. How much does it measure to be? 0.5. So you were asked to measure it as well, didn't you? It says calculate it, and if you measure it, it also gives you 0.5. Okay, a unit circle. You've got a circle of radius 1. If you have an angle of 30, this distance here is 0.5, and it's always the sine of that angle. Let's try another one. Can you do the next one on yourselves? If I grab hold of mine, can you do one that's 45 degrees? Could you calculate it? You might have to use your calculator and press sine of 45 at some stage to do a calculation for your height. 45. I'm only showing you one on this one, but you can see mine over there. Write down the rule. Opposite is the height, and the hypotenuse is always going to be 1, isn't it? You're going to have to get out a calculator. If you get out your calculator and do that little calculation. Now, I'm also going to work it out there, but I'm also going to measure it. How much does the height look like over here? How much does that height look like? It's bigger than 0.5. How much does it look like? About 0.7. what does your calculator say? What's the sign of 45? This one says 0.7071 or something like that. Some people will learn later on that's the same as root 2 on 2. But nevertheless, there we go. If you measure it, it looks like this distance here is about 0.7. What are we seeing? We're seeing that if you do the sine of something, the sine of the angle, it seems to be the height. If you do the sine of the angle, it seems to be the height. We're looking on that rule there. Can you do the third one, please? I'm not going to do this at all. You can do the calculation yourself and see how you go. It looks like about 0.86 to me if you measure it. A unit circle is a circle with a radius of 1. Okay? And if you've got a unit circle, that means if you know the sine of the angle, it will give you the height. I don't want 8606 or something. So if you want a copy of this, this is on the resources tab as well. Now, when you finish it, I do want you to write in big somewhere, preferably in another colour, that sine theta is the height. That's what we experienced from that. So maybe somewhere big, this is just notes of exploring. You write a big thing, right like as big as I've done it on yours. It should be that the sine is the height. Okay. I'm going to take it to a little interactive, and this is on the resources as well. And let's have a look here. Is that one there? Is that our first one? 30 degrees? 30 degrees. How high is it? The height of that triangle does look like it's about 0.5. Watch what happens when I have to play. I'd like you to have to play with this a number of times. As I increase the angle, what's happening to the height? Going up. What's the biggest it's going to get to? 1. What's going to happen when it gets bigger than when it gets to 90 degrees? Be 1. What happens when it's bigger? Have a look where I've got. Sorry, I'm trying to get to 150 degrees. I've just degrees right to do that. Close enough to 150 degrees. 150. How much do you reckon the height is? It looks like about 0.5 again. So we're going to come across this sort of concept of equivalent angles later on, and we'll do lots of work about that. But maybe I should have the radius shown at 1 and the height. Okay, so what happens? What will the height be when I get to 180 degrees? 0. What will happen after 180 degrees? What? A negative height. What's the smallest height it can get to? -1. It's a funny sort of thing to say that, isn't it? And then it's still being negative. What happens when you get around to 360 degrees? What will the height be? That's what we're going to play around with. Starting at 0, height getting up to 1, getting down to 0, going down to -1, height back to 0. So, if you want to have a little play with those, that's what we're looking at. Okay? Over the page. Let's do exactly the same thing for cos. So in cos, have I got another one of these? I have. Can you draw a right angle triangle with hypotenuse 1, and we want you to calculate the length. Previously you were working out what the height is, and we discovered that sine is the height. Could you try calculating the length? What's the rule again? Okay, let's have a look. So you've got 3 sets of calculation to do. we've got an adjacent. Maybe I should put it over here. Get rid of that. I've got an x this time. I want to know that, so I've got an adjacent and a hypotenuse. So cos is adjacent over the hypotenuse. Cos 30 is, how much is the adjacent? What we want to know. How much is the hypotenuse? 1. The 1's always going to cancel out. You keep seeing it happening. So x equals cos of 30. Do you know what cos of 30 is? No, it's not a half. The cos, it looks like, cos is the length, isn't it? So it's bigger than 0.5, bigger than 0.7. It looks like, can you try it on a calculator? What's cos 30, please? Some people know it's root 3 on 2. That's a great thing, we'll learn that later on. In a decimal, it's 0.8606. If you measure it, the height is 0.5, we can see that there. How long is that length? 0.5, 0.6, 0.7, 0.8 and something. Maybe 0.86. And we're going along. Could you try those 3 calculations? You've done an angle of 30. Could you try your next triangle and do an angle of 45? So you should have that written on in this section here of your first page, and you can have a go at the other ones, please. I'm trying to show you that the sine is the height in a triangle, and cos is the length of the triangle. In the unit circle, we always start at 0, and then we get all the way around to 360. In methods, we only ever work from the x-axis. Who are the specialist people? A couple of people do specialist maths? Some of us, yeah? So the specialist people, you'll do a little bit of work of measuring things from the y-axis. So 90 degrees, 9 plus and all that sort of stuff. We don't do that type of maths, yep? But you guys would. Okay. Cos 45. What's the cos of 45? Your calculator says. Some people know that it's root 2 on 2. Or eventually will. No. Let's measure the length. It looks like about 0.5, looks like about 0.7. Finally, for your third triangle, can you do your calculation for the third one? Are you following to the end? Yeah? Okay, that's okay. Once you're following. In this one here, I've got the 60 degrees. What's the length doing? The length is about 0.5. So if you get this lesson, it will really help you out a lot. If you've got those done, can you now write again in big writing? You've got plenty of space to do it. Can you write that cos theta equals the length? We're doing the cos of these angles, and it seems to be working out the length. Okay? So we're going to come back and reteach you all of this stuff. You've got 30 seconds, then we're going to have a sort of interactive for cos. I'd like you to have a play with this little one and see how you go. Okay, I'm going to start with 60 degrees because I like 60. My friend.
Yeah, they're like a big
Okay, back to me. Let's look at this one, please.
You guys got communicating
Thanks very much, great help. This one here is 60 degrees. That's all right. Thanks for the time to settle. Okay for the time. This time, when it's 60 degrees, the length is 0.5. Let's have a look as the length changes. If I start back close to 0, what's the biggest the length can be? How long is it? Never quite gets down there, but it's getting closer and closer to 1. We'll learn about limits later on, about things getting closer and closer to 1. So, but what does the length going to be when we get to 90 degrees? How long is the triangle? How long is this little bit here? It's getting closer and closer to 0. The height's getting closer to 1, but we are looking at the x, I suppose, that little x down there. It's getting smaller and smaller. What happens now to the length? Once it's bigger than 90, it's a negative length. So it's a negative number. It gets bigger and bigger. What's the biggest negative it gets to? It's -1. That's in fact the smallest number, funny thing to say. What happens to the length now? It's still negative, and what happens eventually? The length goes back to 0 and goes back to being positive. So there are positive answers. If I look here at cos of 60, I can get it to go to 60. How much is the length there? 0.5. If I go to 100 and, what's that one there? When does it equal 0.5 again? 150, it's got a length of -0.5. So we will learn about, if we know what sine, someone tells you what, so the cos of 30 degrees, you'll be able to work out the cos of 150 degrees. There's going to be these equivalent angles. So you should know a little bit about both. Over page, got a new one? This is where Mr. Francis looks a bit silly, and he talks about birds. Birds. What's Mr. Francis and birds? It says on your sheet, could you draw 4 right-angled triangles? They need to have a hypotenuse of 1 and an angle of 30 measured from the x-axis. There is one of them. Where's the next one? Let's speak a little bit. Now you should know the height's going to end up being about 0.5. It's going to be level with that one over there. So even though I haven't put it on, there's 30 degrees. There will be another one down here. And again, if you can cheat a little bit, they should always be coming to that height of 0.5. There's the 30 degrees. And over here, again, it should come down to exactly that 0.5 line. Does that make any sense? Mr. Francis and his birds. We talk about the x-axis, and it's like a bird taking off. The angles we measure up from the x-axis and down the x-axis. Can you look at Mr. Francis being silly for a second? So there's the x-axis. We always measure up from the x-axis and down from the x-axis. So there's a really silly image to think of Mr. Francis doing up. In specialists, they'll do other sorts of things, but we're always talking about equivalent angles in that way. Have you drawn those? Okay. Sine. What is the sine of 30? Which one's sine again? Is it the height or the length? Have a look. Sine is the height. This one here, how high is that there, please?
0.5.
0.5. Cool. Sine of 30 equals 0.5. Can you write 0.5? You got someone to write that? What is the sine of 150? Let's have a look. Here is our angle round to there, 150 degrees. How much is the sine of that triangle? How high is the triangle? 0.5. Sine 150 is 0.5. Sine, add on 30 degrees would be 180 plus 30 is 210. Careful, how much is the height this time? How tall is that? Negative 0.5. If you've got that, you really are flying. And then finally, the sine of 330 degrees equals, what's this height here? Negative a half. If you can see those things, you're really getting your head around the core of the topic. Can you copy down exactly the same numbers into the next four numbers? Because this is 0 plus 30. The next one's 180 minus 30. The 210 is 180 plus 30. That's 360 minus 30. So you should have the first 6 numbers in. Can you write the rest of the numbers in, please? So write the first 3 in. I've got them in. And you write them again twice. So you've got to write them down once, and then write them in again a second time. Cool. Sine 30 is the same. Sine 150, that's 150. So you just copy all those numbers down there. 4. Okay. Bottom half of the page, please. What is the cos of 30, please? Just 2 decimal places, 0.86. Fantastic. So that distance there is 0.86. What do you reckon this distance here is? How much is that one? Is it a positive or a negative? Cos of 150 degrees is negative 0.86. Remember, cos is the length. We want to know the length of the triangle. When you measure it, it's 0.86. So this length must be the same. And the one underneath it, it must be negative as well. And then finally, what's the length of your last triangle round here when we've gone, when we've gone 330 degrees around? How much is that? Positive 0.86. And again, they repeat down the page. Is it 866, is it? Oh, okay. 8 he's gone with 2 decimal places, thank you. But we're going to use exact values, so that's much better. But we're going to use the exact values to say it's the square root of 3 on 2. Yep.
Can you
Yeah, question? Yeah, go on.
Yeah. Because that's that.
They are exact, so you just write those numbers again.
That be a negative.
That should be a negative. So the last one, I've made an error. Can you see the last one? It says cos 360 plus 30. It should be cos 360 minus 30.